In the last video, we saw how we could use the recirculator mix dial and the dials in the recirculator control panel to control your reverb or echo parameters. Now let's see how we can do that under program control in the matrix. What we'll do first is make sure our dials are set to 0 because we want to control things in the matrix. The master section has two columns under the recirculator control, and those can be used to set one of the 4 recirculator control parameters. So you can only control 2 of the 4. The other 2 you'll have to set with dials. The second column also allows you to control the mix setting, which is equivalent to using the recirculator mix dial. To start out, let's use constants to make this easy. I'll set the mix to a 1, which again is equivalent to setting the mix dial to max. Because my decay is set to 0 right now, even though recirculator mix is set to max, I get my dry sound. If I select on the first column R4 and set that to a 1, I'm setting that to its maximum value. That would be the same as setting the decay dial to max, and that should give me my max decay now. And it does. Now if I turn off the mix setting, since the mix dial is at 0, that in effect is not sending anything into the recirculator. I should be dry again. And I am. And if I wanted to, I could turn that on, and maybe I only want a little bit of decay, maybe 0.3. So that should give me just a little, hardly noticeable. Let's pump it up to say 0.6. You can hear it a little better. Remember, here's dry. So that's how you can control things with constants. But it'd be nice to be able to do something dynamic, and we can use formulas in there instead. And what we want to do there is use a formula that will be either controlled by a shape generator or controlled by a barrel. To make this easy to see, let's control R2, which is our darkness parameter, because we can easily see that on the spectral plot of our noise graph. So we'll create a formula, V, and what we'll do here is we'll set this to the second barrel. We'll set it to a max of 1. We'll create a second barrel. We'll call that darkness. Done. That will go in my formula from 0 to 1, and I will use that in the darkness column. Remember, I've set the recirculator of that first column to R2. This is going to be equivalent of setting darkness with my barrel instead of using the darkness dial. Let's see what happens. I have the mix set to full. I'm not worrying about decay here because darkness will affect my sound without that. Let's bring up our noise graph, and as I play, I'll move the darkness barrel, and we should see that roll-off come in. There it is. So that shows you how you can use a barrel to control one of the recirculator parameters. Let's do something a bit different. Let's use another formula. This one I've already programmed in. What this will do is it'll set W going 0 to 1, but it's using a shape generator, SG1 here, that I set to a very slow value, and I've set that to the Han shape that will be a unipolar 0 going up to 1 and back in a sine-like motion. So I should see my darkness come in and go out as I apply this formula U here to the darkness parameters. You can see that darkness parameter is moving in that sine-like shape. And of course, if I wanted to, I could go back and make that a much faster shape generator motion, and now we should see that happening twice a second. And that's exactly what happens. Let's try something else. I've created a simple program using a wave bank with a sawtooth, tracking X on the fingerboard, and I put out 0.25 of this because I'm going to gate it. I'm not going to use Z. I'm doing that so I can see what's going on better in my spectral graph. So here's our sawtooth wave. As I expect, descending harmonics, all the harmonics there. What I'm going to want to do now is program a swept echo, and I'm going to want to use barrels to control the depth and rate dials. Why might I want to do that? Well, maybe I don't want to expose for the user all those complex controls. I just want to control those two parameters with a barrel. So we'll go in, we'll create two barrels. 1 equals depth and 2 equals rate. We'll create a simple formula for each, going from 0 to 1. Remember, the values we set in the master section go from 0 to 1, which maps 0 to 127 on a MIDI dial. We'll set our first formula to the first barrel. We'll create a second formula going 0 to 1. We'll set that to the second barrel. So we're all set up and ready to go. We'll set those to mins. And now what we want to do is use our swept echo. We talked a little bit about this in the first video, but we really didn't go into detail on what this modulation, depth and rate actually do. We can see that very easily with the sawtooth wave. Now what we'll do is we'll take the recirculator and we'll set that to full, and you'll see what happens to the sound. I don't have anything else set here. All of my swept echo controls are at the minimum, but just setting the recirculator on completely for this preset, you can see it imposes a kind of a oscillating element, totally reshapes the sound and carves out these little triangular patterns in it. That's just my bass sound. I haven't actually applied the echo yet. Now let's see what happens when I start applying just rate and depth to that. I'll do this with the Kenton controller. Play a note, and first I'll just play the depth. Well, you can see that changed things. Again, it made the sound stronger, but it also changed the spectral content. You perhaps could use that in and of itself, but it's really meant to be used with the rate. Now when I start applying rate to that, you'll see what happens. So we have depth at its full amount, and I'll increase rate now. You can see why it's called the swept echo. We have this modulation, kind of this sine wave like modulation that's sweeping over this at some rate that we can apply and at a depth. You'll hear as I turn the depth down, the magnitude of that sweep lessens. The depth really kind of turns on that sweep. And then from there you can adjust its rate. That gives us a much better idea of why it's called a swept echo, because we have this modulation sweep going over it. Now if we want to programmatically control that, we'll just put our A and B in our recirculator R1 and R2 columns, and what we'll do is we'll turn down all the values because we want to control them through the barrels we created. Now let's reduce our view, and maybe we'll put that down here so we can use our barrels and look at the graph. So here we go. There's our sound without anything on it. Now let's bring in a little depth and start that modulation. Very easy to do, and of course we can actually turn up our echo now and then we can sweep it. Well, you get the idea. Now let's take a look at the LR column. This, as opposed to the SLSR, which are inputs into the master section that go through all the processing. If you put something in the LR column, it is unprocessed, and you can alter the ratio of the processed to the unprocessed using this M column. Let's take a look at that. We're sending the gated sound out now through SLSR. Let's do the same thing through LR. Now, because the M is set to 0, I'm going to get the same echo that I did before. But if I set this M column to 1, now what happens if I press the fingerboard? I get absolutely no processing. So if I set to 0, I get the fully processed sound of whatever I set to SLSR. If I set to 1, I get the fully unprocessed sound of whatever LR is set to. Or if I want, I can set it to some intermediate value like 0.5, and now I'll get half dry, half wet. You can hear the initial attack is much drier, but then the echo comes in. And what happens, say, if I create a shape generator now? I'll set this to a rather slow value. I'll create another formula, C. I'll set that to my shape generator. I'll set that on format, this sine-like format. I'll set this value so it goes from 0 to 1, so it's slowly going to go from processed to unprocessed and back again. If I put C there, let's see what that sounds like. I think what we want to do here, instead of gating this, let's just always make it constantly on. You can hear, if I happen to be in the section when it's on the dry side, it'll start dry and then go wet and then go dry and then come back in wet again as the echo dies away. This might sound better if I make this faster. So let's make this more of an oscillation. Let's say 3 times a second. I add my own oscillation on top of a modulation. I think you can see how this can be useful. Now let's turn our attention to the convolution responses. I think of these more as sonic filters that can change the spectral content of your sound. But let's listen to what Ed and Leopold each have to say about them. Ed says, concerning the convolution settings, it is helpful to think of the convolution source material as a brief piece of audio that the continuum sound passes through. Every sample of the continuum passes through every sample of the convolution sequentially, so it creates all sorts of changes to harmonic content and tends to smear the audio across time. It's like a string going through a guitar body. Lippold has this to say: when they are applied before the recirculator, you can think of them as a coloration and maybe a sense of space. They are stereo convolutions that correspond to various materials an acoustic instrument might be made of. When they are applied after the recirculator, they might correspond to material the walls of a room might be made of. At least that's how Lippold hears it. The convolutions are normally 128 samples long, but you have control over this and can make them shorter. Sometimes a shorter convolution is better because it blurs the sound less. Sometimes also it has less low end if you make it shorter. Most people do this by trial and error. Now, the one thing I can say about the convolution responses, and I agree with Lippold, that you just have to experiment with them, because while it might say wood, metal, guitar, waterphone, or any of the other choices, it doesn't mean that if you set it to that, it's going to sound anything like a guitar or an Autoharp or metal. It might lead it towards that kind of a response, but you're going to have to try and set a sound to be metal if you really want it to sound metal. Just setting it to metal on a string sound is not necessarily going to make it sound like metal. Let's go through a few of these, though. You can set any one of the 4 possible options you have here to any one of the convolution types. Now, typically you might want to set them to different things, but sometimes you might want to set a couple to the same thing if you want to just apply the length or tune parameters changing on a particular convolution. We'll look at that in a second. Let's not worry about length and tune right now. We'll keep them at the defaults at the full 128 samples. This is a MIDI 0 to 127 and the default tune of 64. Let's play a sound that we have. We have our sawtooth sound that we're running through a digital reverb with some diffuse darkness, damping, and decay. Makes it sound a little sawtooth stringy. But let me play a note, and now we'll go to the convolution applied before the recirculator column and set that and see what happens. We can also go and set convolution after recirculator, do one or the other or both. So let's turn on the full amount, the full wet-dry amount of convolution so we can hear it better. But you can set this anywhere from 0, which would be off, to the full amount, which would be 1. Let's start. I have this disabled, so this will be 0. What the wood convolution would sound like applied to the sawtooth sound we have now. And what's with it without? Obviously, there's a great spectral change going on here when you use some of these convolutions. So now let's just ramp through wood, metal, guitar, and waterphone, because those are the 4 that I have set here. If I set this to a constant value, 0, 1, 2, 3, I will drive right to that sound. I can also set it to some intermediate interpolation value that'll give me some kind of mixed value between wood or metal and guitar, or you can sweep between them using a shape generator or a barrel as we did with the recirculator. Let's set it off. Here is wood. That's 0. Let's set it to 1 to drive it to metal. Back to wood. A little different, but again, doesn't necessarily mean it sounds like wood or metal. Let's drive it to guitar now. That actually sounds louder, but more muted. And let's go to waterphone now. And we could try something else here instead of water. Let's drive it to Autoharp. You You just have to experiment with these to get one that's appropriate for the sound you want. But you can see they can drastically change the spectrum of your sound. Let's apply them after the reverb now. So here we'll turn it on fully after, and let's do the same thing. That would be wood. Here's metal. Guitar. And Autoharp in this case. And if you apply them both together, you can have one type before and another type after. You can really accentuate the sound. You have to tone things down normally if you do that. Perhaps to give you a little better idea of what's going on spectrally with these convolutions, I took a sawtooth wave, I turned the recirculator dial down, so I have the unprocessed sawtooth wave here, and it's a waveform that I would expect, all the harmonics descending in that 1/n pattern. And then what I did was just introduce pre-recirculator convolution on the waterphone, and you can see with the pre-recirculator convolution it starts to change the higher harmonic structure considerably. The lower harmonics are not changed that much. Then what I did was apply it both pre and post recirculator, and you can see what it did was take the spectral shape that was carved out on the pre-recirculator convolution and basically amplify that, because it's being applied both pre and post now, and we really carve that up quite nicely, and that will create a convolution that will be perceptibly different than the original. Now let's talk a little bit about the length parameter and the tune parameter. Here's what Ed has to say about those. Changing the length parameter will progressively truncate the end samples of the convolution source from 128 to 1. If less smear is desired, reduce the length of the convolution, but you can hear that it affects the sound in a sort of non-predictable way, since the sample itself is nonlinear in values. Another way to reduce the smear effect is to try a mix value less than 1. Here's what Ed has to say about the tune parameter. Changing the tune parameter changes the pitch of the convolution. Values less than 64 lower the pitch, and values greater than 64 raise it. Generally, it will sound brighter above 64 and duller below 64. This tune parameter is great to tune a preset so it sounds good in a particular key. All convolution samples have resonance points at various places. You can tune a convolution so a particular note has its root or a particular harmonic higher. Let's do some experimenting with those. Let's remove our convolution after. We'll just use it before, and let's say we use the metal. We'll take the length of that all the way down to 0. You can hear what it does. To midway. And what would happen if we did the same thing, convolution after, take that sample all the way down to 0. Again, it really mutes everything. And to mid. That sounds very much the same. If I put them both together, take it back up. Now you get the idea that you can play around with that length to both smear and change the magnitude of the sound. Now in terms of the tune, this is a little difficult to hear actually. So if I take the tune on, bring it to 127. Let's bring it down to 0. It changes more the amplitude of the sound. Because it's the convolution pitch it's changing. It's not changing the pitch of your sawtooth wave itself. You just have to play around with these things. In fact, Ed even sent me a little program to test this that I modified a bit, and here's an example of what can happen when you use the same convolution. Here Ed uses Waterphone 2, and I set the tune to 0 on the first convolution response. On the second one I set it to 127, and now in the interpolation column there's a formula that uses a slow shape generator to move between those two, and you'll hear what happens now when we have that convolution change using the same convolution value that Ed is interpolating between 0 and 1 with a tune of 0 to 127. You can hear using that tune function on a shape generator makes the sound louder and softer. It doesn't change its pitch higher and lower. So you really have to experiment with these things because they can greatly change your sound. You can just think about what you can do with different combinations of recirculator controls and convolution responses that can be dynamically moving from one to another. An extremely innovative thing that Ed and Lippold have created here.